Okay, now you have a little closer look at this wetting band, and what happens sometimes is these splines get a little burrs on them, and it keeps this bushing from sliding off of those splines. If that's the case, you may have to take a file and just very carefully knock those high places off. You don't have to get too wild. All you want to do is just get those little burrs off, and then you should be able to slide the bushing off. You can see this one is a little tight, but it is coming off. There you go. And you see how the inside of that bushing is made. See how it has the little internal splines? And that's why it's such a close tolerance there. Okay, let's go ahead and get the shaft out of the drum. Okay, while I have the shaft out, there's another area I want to check for wear right here. These two slip rings here. Now they happen to be in good shape. They turn easily, they're not broken. And these two slip rings ride inside the stator support down in here. So I'll put my finger down in there and see if there's any burrs or if it catches my finger. I might feel just a very slight unevenness, but for the most part, I believe it's in good shape. So that's a good sign. If you had damage in that area where these slip rings ride, most likely you will have to change the stator support snout, which is replaceable. Now let me just take a quick inspection of the direct clutch drum here. You may hear me call it a direct clutch or a high gear clutch. The bottom line is the clutch that's on the inside of this drum, when it applies, you have high gear. All right, let's take a look in the front first. What I want to do is feel down in this area, just like I did on the inside of that stator support. I want to check to see if there's any divots, any little valleys. I want that to be nice and smooth, because this area is where these slip rings ride on, that's on the pump. And I already determined that these looked in pretty good shape, and it does feel like the inside of the drum here is also good. If you had a real bad where you could catch your fingernail on it, you would have a marginal unit and you would need to replace the drum. Now I look across the top of it here. This is where the band rides, and when I say the band, there's only one band in a Powerglide, and that's for first gear. And actually, I don't mind the discoloration here, but when I run my thumbnail across it, I can feel some ridges right on this one edge. I don't like that. This might be a marginal unit. I want it to be real smooth. If I have little bumps or little ridges, that can hang up on the new band and actually prematurely wear out the band. So we're probably a little bit marginal here. Now look at the sun gear on the back. Looks pretty good. Don't see any broken teeth. I think all in all it's pretty good. A closer inspection will come later when we clean the parts up. Reach in here and pull the band out and take a quick look at that. Well, you look over here, you definitely see some wear. That doesn't look too good. But when I rotate the band around, take a look at this area. The material is actually missing from the band. You can also see shiny areas here. That's where it was metal to metal on that drum. That's why that drum is damaged on the one side. And if you remember, when we pulled the pan, there was little pieces of band material down in the pan. Well, there is where it came from, right there. It is actually delaminated and fell off of the band body itself. You know, that's of course we're going to replace the band anyway, but that was not good to see that. Okay, we look down inside the case and we see the end of the planetary. Now on a Powerglide, the planetary is actually attached to the output shaft. It's a single piece. And if we look closely down between those little pinion gears, we will see a little Torrington bearing. Okay, now because this planetary is a 1.82 to 1 ratio, that little Torrington bearing is captured in there. It will not come out. If this happened to be a 1.76 to 1 ratio, that hole in there between those little planet gears is larger, and that bearing will come out. As a matter of fact, it could have come out when I removed the input shaft. But because this is a 1.82 to 1 ratio, it's captured inside that planet. Now to remove the planet and output shaft, you just simply have to pull it out. But what I need to do is to make sure the shifter is not in park. If it happens to be in park, there's a little park and paw on this side, and it will be stuck on one of these little teeth. That's the park and paw teeth that's mounted to the planetary. So I want to make sure that it's not in park, or otherwise I'll have a kind of a jam up situation there. And I did verify we're off. And now I'll just kind of support the back of the output shaft and the planetary area, and I'll slowly just pull it out of the case. And several little pieces will come out when I do this. All right. And what you see is the output shaft plus the ring gear here. Now that should slide right off. We'll just pull it right off the shaft. And we'll take a quick look at these parts. Okay, the teeth here that engage the reverse clutch, which is in the case, we haven't gotten to that yet. That looks pretty good. I don't really see any damage there, nothing I can catch my fingernails on. This area here that kind of rides next to the pressure plate in the back, there is some metal contact there. That definitely has touched the back of the case. I don't like the looks of that. On the inside here where you see the teeth that ride up against the outside part of the planetary, that looks in pretty nice shape. Alright, the planet itself, I don't notice any problem with the teeth. They all look pretty good. On the back here there's a Torrington bearing. We'll take that off and look at it. This side, there's really no top and bottom to it, just the feel of it. I believe it's okay. I don't think it's damaged. If you turned and you felt all kinds of little click, 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 that means most likely that needs to be replaced. I believe this one's okay. Okay, back further in the case you have the reverse clutch, and that clutch comes on in reverse only. And in a racing transmission, when you have the trans brake on, it is also engaged. Now it's held in there by a big snap ring. What you have to do is find where the opening, the split of the snap ring is, and remove it. Okay, there's the opening right there. And what you can do, you can use one of those little pick tools to get underneath of it. Actually, I have a screwdriver that I cut a little groove in it, and I can get underneath of it that way and should be able to pull it right up. Alright, get the snap ring out. And I'll just reach in and pull the clutch pack out. And what you'll have is the top pressure plate, and then you'll have fiber, steel. Looking at these, they're not horribly worn, but they are very, very deteriorated. And on the very back, you'll have one more steel, and then you'll have this little wave spring. Now this was put in there, it's got like a little wave built into it. What that was for is to cushion the reverse, so when you put it into reverse you don't have a real harsh engagement. For racing, that will be left out. Now all the way back in the case you have the reverse clutch piston, the retainer and spring set that holds the piston in place, and that needs to come out. That's where the spring compressor comes into play. Now here's the universal type compressor I have, and you see how the thing will work. This little area here will push up against that retainer. I'll send it all the way through, and then I'll put the washer and nut on the backside, and as I tighten up on that nut, the compressor will push down on the retainer, squeezing the springs in, and will reveal a little snap ring that goes all the way around it. And I need to find where the opening of the snap ring is, and as I get it compressed far enough, I'll be able to use like a little pick tool and pull that snap ring out. Now I have modified my little spring compressor that I built, I brought the little studs in, and that should, looks like it works pretty good. The little ends of these studs hit the retainer about in middle position, about the mid position on the retainer. However, it'll be a little bit easier to see in the video by using this commercially available compressor, so we'll use it. Now only compress the retainer just enough to reveal that snap ring. No need to overly compress those springs. That should do it right there. Okay, with it compressed now, I should be able to get under it with this pick. You could also use some snap ring pliers. There we go. Okay, I'll go ahead and take it off now, and we'll take the piston out. And we'll take the retainer out, and there'll be a bunch of springs behind it. There we go. And pull all those springs out. And then we should be able to get the piston out. Sometimes the piston will come out by hand, just by wiggling it a little bit. If not, you can blow air in the back of it. Okay, what I want to do is blow air into this hole right here, next to this little horseshoe. And if this was a rear pump model, I would be blowing into this hole. So, and understand the transmission is upside down, so understand the orientation here. Now what I want to do is to blow into this hole, but because the valve body is off, I got to stick my hand over the hole which would be going to the valve body, and I should be able to get that piston out. Okay, I think it's knocked out now. All right, put that aside. And now we'll take the servo off. 3 bolts, 9/16 heads. All right, there's a real strong spring behind this servo. Sometimes they'll pop out all by themselves, but if they don't, just persuade it a little bit with a screwdriver and just work it back and forth and it should come on out. There we go. That's the cover. And then we'll pull the servo out, kind of come in from behind the screwdriver. And there's the servo and that big spring. And I like to feel down in here to see if I feel any grooves that's left by that sealing slip ring. This one feels pretty good. Okay, we're almost finished with the disassembly. I've spun the transmission around. I only have one more thing to do, and that's to take the linkage off. After that, I'll clean up all of the parts. We'll do a more thorough inspection. We'll decide which parts will be reused, what parts need to be replaced, and of course the things that will need to be modified to make it a racing transmission. Now, 3 components will be worked on separately, and that's the pump, the clutch drum and all of the parts in the drum, and the valve body. Now ultimately this transmission will be set up for a trans brake, so therefore we will use a store-bought valve body that already has the trans brake attachments built on it. However, for those people who are running foot brake drag racing, we'll take the stock valve body and we'll modify it and make it a manual shift valve body using one of the available kits. Alright, let's go ahead and finish disassembling. We'll remove the kickdown linkage which is attached to the inner shaft first. Okay, we'll be using aftermarket linkages on here, but if you were going to reuse any of this linkage, be sure you remember the orientation of how the linkage is attached to the shaft relative to the levers on the outside. Okay, that one's pretty loose. There you go, got it out. Now I'll take the other Allen screw out, which is holding the shift lever and rooster cone. Sometimes that's what this is called here. Okay, sometimes that throttle linkage or kickdown linkage will be a little bit tight on that inner shaft. So I'll take a screwdriver and kind of come in from the back to help push it out, and then just pull on the lever on the outside, and I should eventually be able to get it out. There you go. And pull the linkage off, take the shaft all the way out. Okay, and then the same thing goes with the shift lever. Again, it'll be a little bit tight, so we may need to persuade it just a little bit. Have to be careful, we don't want to break anything. May have to come in here where the two pieces are kind of put together and open it up just a little bit, and I think that will do it. There we go. And just kind of be careful, and it should eventually come on off. Take the linkage off, and the inside lever with the rooster cone is hooked to this part here. Of course, this is going to the park and paw mechanism right in this area. Now, I don't really need to go any further. The park and paw itself is held by a little spring, and you have this little guide plate here. I can take the guide plate off and take that spring out, but there's really no need to go any further in cleaning up the parts. And lastly, we'll remove the shift lever seal. Just get under it with a screwdriver. It may take a little bit of effort. There you go. Okay, I'll be cleaning up the parts here shortly. Right now, I want to take a few minutes and show the differences between the two gear ratios. Now, you remember this transmission had a 1.82 to 1 ratio, and the components to that is over here. It's basically 4 parts. Right here, I have a 1.76 to 1 ratio with those parts. Now I'll compare the two so you can see the difference. Okay, let's look at the input shafts first. Here is the 1.82, and this is the 1.76. Remember I said that the 1.76 is slightly longer. So let me put the, let's say the converter in together. We'll put them side by side, and you can see the 1.76 is a little bit longer. Let's take a closer look. Okay, you can see just about everything is the same to the slip rings and the first set of splines. But when you get to the second set of splines, that's where you see that the 1.76 has a little bit greater offset. It's a little bit further out. And so remember, the 1.76, the overall length of the input shaft is 12 7/8, and the 1.82 ratio is 12 5/8. Okay, next let's look at the low sun gear. This is the one from the 1.82 to 1. The diameter of this gear is approximately 1 5/8 inches. Let's compare it to the low sun gear from the 1.76 to 1 ratio. It's much larger in diameter. It's about 1 13/16 inches. And again, remember how I said that the Torrington bearing that's in the planetary is loose and will actually come out of the 1.76? Well, you can see why. This sun gear, which goes down into that planetary, is much larger in diameter. Now let's compare the ring gears. This is the one from the 1.82, and this is the one from the 1.76. You can see they look about the same, but one distinctive difference is this little ledge here. You see that the 8:2 ratio has this little ledge on the ring gear, whereas the 1.76 has it's a chamfer there. The biggest difference you can notice is the diameter. You put these together and you can see that the 1.76 is much larger in diameter. Okay, now let's look at the planetary itself. Now this is the 1.82, the one that was in this transmission, and you can see the planet body is made out of, it's kind of a stamped steel arrangement here. And the park and paw gear looks like it's actually attached to that stamping with some rivets. And of course you have the different pinions that's on the inside. All right, let's compare that to the 176. Now you can see there is definitely a difference in the size and the diameter, much larger. Also, you see that the body is kind of a single casting. You see all of this area plus the park and paw gear, it's a kind of single unit. Also, when you compare the pinion gears, at least the outside ones, they're much larger in diameter. And of course, where the low sun gear goes, you can see that the 1.76 definitely has a larger hole there. Okay, I believe you can identify the different gear ratios now. Remember too that on a 1.76 to 1 ratio, the splines are slightly larger in diameter. In fact, the 1.76, everything about it is bigger. You have bigger planet gears, you have a larger low sun gear, the planet body itself is heavier duty, everything about it is stronger. The 1.82 to 1 ratio is really not very good for drag racing. It shouldn't be considered unless you had a very lightweight car with a relatively low horsepower engine. However, when it comes to round track racing, that's the preferred ratio. They're looking for a low rotating mass. In fact, they go a step further. They'll take that stamped steel body and drill it full of holes to lighten it up even more. But in drag racing, you have very high shock loads, especially with a trans brake. So the 1.76 to 1 ratio is really the only one to consider for drag racing, unless you're going with aftermarket planetaries. Okay, it's been a few days. I've cleaned up all the parts. Now you don't see the pump, the direct clutch drum, or the valve body on the table. Those parts will be cleaned and built up later during the component buildup part of the video. But what I have done is I cleaned the case and the extension housing using a pressure sprayer. I cleaned the rest of the parts using a regular parts washer. And what we want to do now is to inspect the parts, see the parts that we'll reuse, and more importantly, the parts that will be upgraded for our example drag car. Now in our example, I'm building this transmission to essentially go in a 500 to 600 horsepower engine in a 2,700 pound to 3,000 pound body weight drag car. As a matter of fact, once this transmission is built, it will be a spare transmission for Robert and Pat, his wife, who both have drag cars. Now their cars are likely in the 700 to 700 plus horsepower range. So what I'm doing here, I'm building the transmission normally the way he builds the transmission for those two cars. However, he's found that once he got into the higher horsepower range, once he got beyond, say, 650 horsepower, what he estimates, he started breaking things that he didn't have problems with before. So in some of those gray areas, parts that are maybe a little bit marginal, we'll talk about that when we get to that part of the video. But what I have done is when I cleaned this case, I found the case is in very good condition. Understand this was probably in a stock vehicle. It wasn't used for racing. So what I wanted to do is to check all the threaded holes in the pump area, in the oil pan area. They all look fine. It's not uncommon to find thread damage in that area. If you do, sometimes you can save the case by putting a Healy coil in it. Again, the bell housing looked fine. In a drag transmission, the bell housing is one area you want to do a very close inspection. Not too uncommon to find cracks there. In the back of the case where the where the reverse clutch is, understand that in a trans brake application, that gets a lot of stress. Can find cracks in the back of the case, so you want to check that area. This one looked fine. The bushing in the case that supports the output shaft, Again, looks fine, but we'll replace it. We'll likely replace all the bushings in this transmission. The extension housing, again, very good. The boss here for the transmission mount looks good. That is an area where you find some cracks sometime. Right where the slip yoke bushing is, again, if it had been in a drag car, you'd want to look at that kind of close, because not only does a drag car, when it accelerates, especially with the trans brake, is suddenly rotating that slip yoke, it's also trying to move the slip yoke sideways and can stress the back of the extension housing. Another thing I want to talk about, you know, we're going to build this transmission. Hopefully you're getting the most bang for the buck. I'm going to show you that you can build a quality Powerglide buildup, you know, without spending tons of money, but you will have to spend some money. There are certain aftermarket parts that are absolutely essential. And no matter what you do, no matter what parts you get, you can still break it. That's just part of drag racing. No matter how you build it, things can break. The more important thing is try to build the best that you can for the money you have, and if you start having areas, if you start having wear, if you start having clutch damage, or you have maybe some breakage, now you know the areas that you're going to have to make some upgrades on your particular project. Now let's take a little bit closer look at some of the smaller parts. Okay, let's talk about our very first upgrade, and that is a deep sump cast aluminum pan. It's very important to add capacity to the Powerglide. It does not typically use a lot of transmission fluid. If you're running a small diameter racing converter, there's even less fluid, but there's a very high demand on fluid. You're adding, lubrication upgrades. You're, putting a trans brake on, that's adding more fluid, and of course you're running higher pressure. All of these things demand to have more fluid capacity. So a deep sump pan is, I think, a very essential first upgrade. There's also an added plus using a cast aluminum pan. That is that it stiffens up the case. The case has a hard life in a drag car. When the band applies, the servo is pushing in, it's actually trying to spread the case out with the trans brake on. Also, the front of the case is trying to twist in one direction, and the rear of the case is actually trying to twist in the opposite direction. So the cast aluminum pan, because of its high thickness in the pan rail area, that's adding stiffness, adding rigidity to the transmission case. Very good upgrade. Next, the input shaft. Now this input shaft is actually in pretty good shape. You'd want to check this for spline twist. Do we have damage back here? And a closer observation, and I can see that there is some spline damage. After all, we remember that the wedding band was a little bit hard to come off. There is a little bit of side wear on this spline. There's no need for me to look at this very much closer than that, since I will be replacing the shaft with an aftermarket shaft, this one right here, and this one uses the Turbo 400 spline on the torque converter end. Again, there's really no need to retain the stock input shaft unless you were dealing with a totally stock car. Any performance torque converter nowadays will have the Turbo 400 spline on the inside. So you might as well figure, an input shaft is your second upgrade. As a matter of fact, this shaft happens to be a universal fit one. Remember, I said that they're two different lengths depending on the planetary. This one actually winds up being slightly shorter than the 1.76, but it's a little bit longer than the 1.82 planetary, so therefore it will fit either planetary. It's worth getting that. The washers, they looked fine. This is the select fit one that's on the front where the pump is. The wedding band, it does have some wear. I think it's going to be fine. I'll do a test fit down in the low sun gear. This is where it rides to make sure it fits fine there. And of course the Torrington bearing that's in the back of the case You know, I had checked it, it felt fine. If there's any question about these type of washers or Torrington bearings, if you have, you know, you feel you're a little bit iffy on it, just simply replace them. I think these will be okay though. The governor support in the back, again, looks fine. I'll likely replace the bushing. The servo, there's always been some debate about using a stock servo. The thought is that if you use the aftermarket type servo that has 2 rings on it, you have a better sealing capacity here, and you're less likely to have a pressure leak past the servo, which will go over into the release side of the servo, which could make its way to the direct clutch. And the thought is that it could engage the direct clutch when you're in low gear. I don't really think that's possible, because when you're in low gear, the manual valve allows for a dump of fluid to the direct clutch. Nevertheless, even without applying the clutch, which could be a problem, certainly if you had a pressure leak in this area, that's not a good idea. So even though Robert hasn't really had problems with the stock type servos, I will upgrade to a dual ring servo for this project. The inside linkage that was in the transmission that goes to the manual valve, this one was fine. There's an area here where you will find some cracks sometime. I'll show you what that looks like on one that is damaged. But this one is okay. And this brings up the next upgrade. The linkage that's on the outside of the transmission that goes to your shifter, you definitely need to go to an aftermarket unit. The one that I'll use in this project is a universal fit. It's designed to fit several different aftermarket shifters, so we'll be using that. All right, the governor was fine. Now, of course, in this application, we're running a trans brake, and the governor will not be reinstalled. However, if you were doing a foot brake transmission and you're running a manual shift valve body, in some cases you need to reinstall the governor just to cover up some holes in the back. I will show you a little trick that you can do so you can leave the governor off and not have that pressure leak in the back of the case. Okay, I don't have the direct clutch drum on the table, but inside that drum is the next upgrade I want to talk about, and that is the direct clutch hub. These hubs get a lot of abuse in a race application. It's a potential weak point, so you definitely should upgrade to a racing steel hub like this one. They're not only stronger, but they tend to have slightly longer splines, which will allow for 1 or 2 more fiber plates to be installed in the direct clutch. All right, going a little bit further back in the transmission, we'll take a look at the output shaft and the planetary. Now, if this had been in a race transmission, you would want to look at the spline area very carefully. Make sure you don't see any twists on it. In the area up here where the bushings ride, you want to make sure there's no gouges, there's no pitting, there's nothing that'll catch your fingernails. This one, of course, feels in very good condition. The planet gears, you want to check to make sure there's no side play. If you have any side play, that means there's some needle bearings on the inside of those gears which are broken. Now, they'll have a little bit of up and down play. You have a little thrust washer top and bottom, and that little bit of end play, I think the spec is it shouldn't be more than 30 thousandths. If you had a lot of end play, most likely one of those thrust washers is damaged or maybe even missing. Then you look down inside it, and of course you have that Torrington bearing. Remember, this is a 1.82 to 1, so it's captured in there. Underneath that input sun gear that's on the inside, there is a thrust washer. What you can do is kind of reach in there and kind of pop it loose and let it kind of fall on its side. That way you can see the back side of that thrust washer that rides up against that sun gear. And if it looks good, which this one does, then that means you're probably in pretty good shape back there. Now, there's no need for me to look anymore at this planet and output shaft because I'm not going to use it. That brings up the next upgrade. You should always, in a race application, even a 400 horsepower engine should have an upgrade of the 1.76 to 1 planetary and output shaft. That should be a minimum requirement for a race application. So therefore, I will be using a 1.76 to 1 planet and output shaft. And remember, it will be a 27 spline output shaft. It will be the later model. I do understand, I believe that some of the very earliest 1.76s actually had slightly different pitches to the gears, and that makes them somewhat oddball. So you don't want to get involved with one of those. You want to use the later style, and this would typically be, you know, maybe 64 or later models, and all of those are the same. They're interchangeable. And along with the planet and the output shaft, I would be using a ring gear and a low sun gear that would be compatible with that planet. Go a little bit further back in the case and you have the reverse pressure plate here. This, of course, is the pressure plate is against the reverse clutch pack. I see some pitting here, you know, there's some scrape marks, but it's nice and flat. There's no cracks in it, and it is not broken. So I don't see any reason in the world that I can't reuse this pressure plate. Behind that, of course, you have the reverse piston. What you want to look at on the piston is to make sure the backside is perfectly flat, and this one appears to be that way. If this piston had have been in a race application with a trans brake, it's not too uncommon to find a damaged piston. What happens a lot of times is with the trans brake applied under very high pressure, this piston, of course, is pushed up against the clutch pack. And the pressure is so severe that the pressure coming up from the back of the piston will actually try to bow the piston in here, enough to, in some cases, it bows it and cracks start to form on the front side here. If you find something like that, of course the piston would have to be replaced. Now in front of this, of course, you have the retainer with the springs in it. And this one, of course, is in good condition. But that brings up the next upgrade, and that is, if you're running a trans brake, you should upgrade to the more, much stronger retainer plus the heavier springs. The idea there is the standard retainer is a little bit thin, and what happens sometimes, especially if you have a lot of clutch pack clearance, there's a possibility of the piston going in so far to engage the clutch that it will bottom out the springs and actually start to distort this retainer. So to keep that from happening, the way to go is the aftermarket retainers, which are much stronger, much heavier material, and they have stronger springs. Now the idea behind the strong springs for a trans brake application is to have a nice crisp release. Understand, that piston is on when your brake is applied, but as soon as you let go of that button and the pressure is released on this piston, you want that piston to go back nice and quick to get you a good release from the brake. And that's where those heavier springs come into play. All right, let me talk about one miscellaneous item, and that's the band adjuster pin. Now this one happens to be in good shape, but sometimes you'll find these bent. And so a good optional upgrade is to go with one of the aftermarket adjuster pins. They're made out of stronger steel, plus they tend to be a little bit longer, which will allow for a little bit more adjustment of the band. Now it's time for the component buildup part of the video. We'll start at the front of the transmission and work our way to the back. Therefore, the pump will be the first thing we'll work on. Now I like to mount the pump some kind of way to make it a little bit easier to work with, and put it on a few blocks of wood. You could stick the stator down into your extension housing. That works pretty good. It's a little bit unstable though. If you had old C4 bell housing, you could just lay it down in that. But what I'm going to do is use this old extension housing for a four-wheel drive. I'm not sure what it came off of, but it sets it up at just about the right height. So you can stick the stator support side down. You have the bolts up. Makes it a little bit easier to work on. All right, these bolts have half-inch heads on them. We'll get those off. And just pull the two halves apart. Take a look. Okay, now I'll lift out the pump gears. Some people like to mark them before they remove them, maybe use a little carbide tip marker. Main thing I want to do is check for wear. Now this inside gear, you may be able to move that back and forth. That doesn't mean too much. But the outer gear, you shouldn't be able to move that at all. That's not to say it won't move a thousandth of an inch, but you shouldn't really see any real movement there. And this one appears to be in good shape. I look at the top, I don't see any radical cut marks on the top of the gear. These gears actually look pretty good, at least from this side. So I'll lift out the center one and then take the outer one out. You have to lift it straight up. There we go. And now I want to look down in the bottom, see if I see any wear in this area. I'll tell you, this looks pretty good. I don't see any little grooves right here, nothing I can catch my fingernail on. I think the front part of the pump body looks pretty good. Now the bushing has a lot of corrosion. Of course, this thing has been sitting for a long time with no torque converter in it. So, you know, obviously you would see probably some corrosion there, and we'll replace that bushing anyway. But this area in here where I wanted to pay real close attention, that looks real good. Also, when I look at the bottom side of the pump gears, again, they look pretty good. Oh, you see some, you know, marks on it, you know, where they have turned, of course, but for the most part, it looks pretty good. Nothing I can really catch my fingernails raking it across there. You know, these pump gears don't look too bad, but there is an area that I have a concern. When I take a closer look at the face of these gear teeth, there's a couple areas that I see that there is some wear. If you look at the face of the gear on this inner gear, you'll see a little place right here. See, there's a little divot. There's a couple of those around the on a couple of these teeth. Also on the mating gear, you see a kind of a similar little divot right there. They're not too bad. I think all in all, these gears are in pretty good condition here. There is one little test I'll make, and I'll show you that now. I'll take the inner gear and spline it into the outer gear just like that, and then pull on the inner gear. See how it pulls the outer gear with it? That's a good sign. That's telling me that those teeth are in pretty good condition. If I splined them together like that and pulled it back and it fell out of the teeth on the outer gear, you would definitely want to replace those that gear set. This one looks pretty good. There's one more place I want to check for wear on these inner gears, and that is where the torque converter lines up with these lugs. Okay, right here. See where the lugs of the torque converter has caught this little tab? You can see the little witness marks there. That doesn't look bad at all. If you would see a big gouge there, you know, a lot of pushed in damage on this little lug, then that would make it a marginal unit. I think this is okay. I don't want to see too much more wear than what I see on that lug. Let's take a look at the other side. Same way. You see a little bit, you know, of wear, but it's not too bad. Not too bad at all. Okay, now I'll remove the O-ring that's around the pump here. I'll use my little pick tool, get underneath of it, pull that off. Then I want to remove the, you know, the front seal here. I think the best way to do that is just take kind of one of my long screwdrivers and go in from the back and then tap it out with a hammer. And I'll just clean this part up. Now we'll take a look at the other half. Now, as with the other half, I want to check for some wear. Normally, this is the area where you'll find the most wear. This is where the two pump gears mesh together right in this area. This one feels real good. I see little witness marks there, but I don't really catch it, maybe just a little bit, but for the most part that's nice and smooth. This back side, same way. You know, you see little witness marks, but it feels nice. If you had a lot of ridges here where you could really feel, you know, there's an indentation, then that would be a case for, you know, possibly getting another pump half. I think this one will be fine. All right, now let's take a look at some of the valves that are in this half of the pump. You see this tall valve that sticks up here, that's the downshift timing valve. If the transmission is going to be used with a trans brake, that valve can be removed. Next to that you have the cooler bypass valve. Now all pumps will have the cooler bypass valve except for pumps that were used in an air-cooled model. Now this pump half does not have a valve in this location. However, earlier pumps will have a valve that looks very similar to the cooler bypass valve, and it's a lubrication relief valve. I think beyond about 66 or 67, that valve was done away with. Now on the inside, in this area here, you have the front pump priming valve. All right, let's flip it over and we'll remove the two slip rings here. Okay, I just find where it's hooked together, and the way I usually do it is I just kind of push in on this side, take my thumb, push on the opposite side, and I should be able to, you know, kind of distort it enough to where it unsnaps, just like that. And then just spread it and lift it right out. And do the same thing on the second one. If you have a little bit of trouble, you could probably use the pick tool on it. I normally can get it. And try one more time here. There we go, unsnapped. And pull it right on off. You can use some snap ring pliers too to spread it open. Make it a little bit easier to get it off. Okay, now I'll take the gasket off. You may have to use a scraper to get it off. I'll just kind of get the most of it off here. And I also want to remove that priming valve. Now there's a little roll pin here that has to be knocked out, and there'll be a spring behind that, and then the valve is behind the spring. Now when I tap that out, I'll use an 1/8 inch punch. As I punch down on it, I'll have to be careful because the spring might get hung underneath of it, and I may need a screwdriver to kind of push in on the spring, you know, to keep from distorting the spring or damaging the spring when I get the that little roll pin out. I should be able to do it right on my little tool here because it's open on the bottom. Knock that on out. There you go, and I'll take a magnet to get the valve out. If I have a little bit of trouble getting the valve out, I may have to kind of push it from the other side with a screwdriver. Okay, I did have to help it out from the other side with my pick tool, and I should be able to get it out with my snap ring pliers here now. There you go. And we flip it over and pull the roll pin out the rest of the way with some side cutters. There we go. Now remember I said that the downshift timing valve will not be used since this will be a trans brake built transmission. So I'll take my pliers and remove it. And may have to kind of work out a little bit. There you go. Put that aside. And now I'll just clean this part up along with the other piece, and then we'll do some modifying. Okay, the two halves are nice and clean. I took a wire brush and cleaned down these splines on the stator support, took that surface rust off. I took the rifle cleaning brush that I have, and I went down the priming valve bore to keep, you know, have that nice and clean so I won't have any trouble with the valve sticking. And I think for now we'll take the front half of the pump and just simply replace the bushing and install a new seal. Okay, what I'll do is one of my little bushing knockers here, I have a 2-inch mandrel that fits just right on top of the bushing. If you look, you'll see that the bushing is slightly countersunk on this side. That's to keep it from interfering with the pump gears. So we'll drive it out from this side. Now I can take a hammer and just beat it out. If you have a hydraulic ram, that would really be better. I'll see if I can just tap it out with a hammer. There you go. And I'll put the new seal, or the new bushing in from this side. I'll use another mandrel that's a little bit larger in diameter. It's a little bit more than 2 inches. And push it in from this side. Now I think I'll do this, you can do it with just by tapping it in with the hammer, but it's a little bit better if you have a hydraulic ram. By installing the bushing from the other side, that allows the bushing to have the proper countersink on this side, maybe 1/16 of an inch. Okay, by the way, when you install these bushings, it's very easy to damage the edge. You know, I have little burrs or little nicks on it. Actually, I had a little bit of damage when I installed this one. And you can take a pocket knife, old pocket knife, and kind of dig around the edge, maybe a small round file, and you know, be sure you get that deburred after you install the bushing. And a good test is to actually lay this on your torque converter. If it slides on the hub of the torque converter, you know you're in pretty good shape. Now we'll flip it over and I'll install the front seal. Now a little tip here is sometimes there's a little garter spring that's behind the lip of this seal, and when you hammer them in, sometimes those little garter springs will flop out. So to keep that from happening, you can take a little petroleum jelly and kind of go down behind that lip of the seal, down there where that garter spring is, and then when you tap this on, it's less likely for that little spring to fall out of place. There we go. All right, now let's look at the other half of the pump, the part that has the stator support. We already previously looked at the splines. It was in good condition. I see little witness marks, but there's really no problem there. Down here in the back, where the slip rings on the input shaft ride, again, I don't feel anything at all, no damage whatsoever. If it was damaged, the stator support can be replaced. You would have to put it in a hydraulic ram, you know, use the proper size mandrel, push it out, and then press the new one in place. And you would see how deep you need to go. It comes up right to the little ledge that's on the inside right here. Okay, let's flip it back around. I want to make sure that this cooler bypass valve is nice and free, that, you know, it's spring loaded, a little ball check there, and that looks fine. No problem there. Now let's talk about some modifications of the pump. Now Robert tells me he basically puts them up stock and he really hasn't had, you know, much concerns. I do believe that there's a couple modifications that you should make, and we'll talk about that.